And thank you for the nice introduction. And I'm very glad to be here participating in this Congress. So I'm here to talk about the first complete description of the tapirs from this Pliocene site that is called Camp de Ninots. This kind of site is a lake environment that was formed inside a volcanic crater. At a certain moment, an explosion of the crater closed it, and then it gets filled by underground water. So it starts to behave like a normal lake. As you can see from the photo, we have a very laminar stratification, so it is a very slow deposition. Nowadays, you cannot recognize the crater in the surrounding, so the erosion actually changed completely. And because you can see the blue line in the screen, that is the recognized definition of the lake through geophysical techniques. Right now, nowadays, we're excavating in Canargilera sector at the 9 and 10 pit. So because of this low deposition and sedimentation in this kind of site, you can recover complete individuals still anatomically connected. And in the last 20 years of excavation, since they started to excavate, we already recover 14 specimens of bovidae, 4 of rhinoceros that are partially complete, and 7 individual of Tapirs, that one of them is only represented by loose phalanxes, so they do not belong to any recognized individual. And just recently, we found that we have one teeth, one premolar of cervidae that has not been recognized yet. So the subject of this analysis, of the studies, are the 6 tapirs that are found mostly complete, except for one that was found in the commercial sector. The other ones are all found in the Canargilera sector, except for the tapir one that is found in the 7-8 pit, that is like 30 meters away from the 9-10 pit. So the number of remains is more or less balanced between all of the studies individuals, and the actual skeletal representation is fairly good, where they're very complete between them, except for tapir 2 that has lost his feet because a fault that was passing right there when he deposited. And tapir 4, because it was a commercial sector, was a kind of an emergency excavation, we could not define yet what was the cause, but we think is again a geological one. So the method applied for this study, for this part of my PhD study, is the percentage of completeness. Because all the individuals are so very well preserved and complete, we were able to finally count the skeletal representation of Tapirus arvernensis for the first time. And not only, we also have different ages included. So this helps in the complete knowledge of the skeletal representation of this species. Also, we are able to do some taphonomic distribution because, again, the specimens are so well preserved that we are able to study not only the differences between any individual in itself, but also between the individuals that are spread throughout the site. So for studying this kind of alteration, we decided to apply a new simplified database that is taking in consideration generic parameters like the cracking, breaking, and crashing, that is just an increasing level of fragmentation. The markings are not defined by any interpretation at all, so we just define a shape like groove and round. And the same is applied for the coloration that we just define. We see a black stain, black, red, and white, that are the 3 main categories that we found on the samples. Also, this alteration are going to be defined by a degree. In this case, is isolated, diffuse, or extended. This is describing a behavior of the stain on the surface of the bones. And for coloration, we also decided to apply a type that is, again, how it behaves. If it is seen as a deposit, or if it's just a stain, or if maybe it's deep, it meaning that there is a loss in the surface of the bone. So finally, going to the result, this is the spatial distribution of all the tapirs. The commercial sector only had 1 tapir and is also the less completed one with 21.8% of completeness, while the most completed one is the tapir one from the sector Canargilera that has 97.46% of completeness. I'm counting sesamoid. I'm literally only missing some sesamoid. So the other tapirs that are found in sector Canargilera are fairly complete as well, except for, again, the tapir 2, that is because a fault is just passing right there. So we just lost the feet, but otherwise it would have been complete like the others. Concerning the tapir 5 and tapir 6 that you can see on the left corner, Especially we see that there is a distribution of the bones that belongs to them that we were able to assign to individuals, particularly one epiphysis that we found 6 meters far away from the main body, and this was found very close to tapir 3 and 4. Not only, if you can see from the images, these two pieces represent a totally different level of alteration, even though they belong from the same bone. So finally, talking about the distribution of the alteration, as you can see, cracking, that is just fissuring of the bone, is more or less distributed everywhere, but we have tapir 1 that present the highest percentage of it. And this is because tapir 1 is the only one that is presenting this kind of cracking that, as you can see, is extended in the surfaces. That's why it presents visually that has the highest percentage of this alteration. Later, for cracking, more or less, you can see that all of the individual present cracking on their surface. And for crushing, again, the same thing, particularly is focused on the axis, on the rib cage and on the vertebral column. This is because the same weight of the sediment is the main culprit for this kind of alteration. As you can see, the scapula is crushed on top of the humerus and it changes its shape. So it is also being deformed by the pressure and the crushing. And this is all due for the sediment weight. So for the round marks, I decided to put them together because for some individuals we have a lot and for others we don't. And for the individuals that present a high percentage of this alteration, they were the most recent ones. So in the stratigraphy level, they are the closest one to the surface. But also we have to define that tapir 1 that present this kind of alteration is the only one that present this visually, that as you can see from the photo. So the difference between these two alterations are all of them signed as round because both of them kind of present a round shape, but the difference is one is an alteration deep, so there is a loss in the surface of the bone, while the other is only a stain. So for the percentage of coloration, we have different distribution. Black staining is more or less comprehensive of all the individual, but we have differences in the white and in the red staining. Particularly, again, we see that near the fold, we have a higher concentration of red and white staining. For what we can understand about the black staining, we have more or less two different behavior. We have a kind of deposit that usually is diffuse or isolated in its distribution. And then we have black deposit, not black deposit, black staining that is extended in the surface. So we have two different behavior regarding the black coloration. The same happened for the white, that in this case, both are assigned to be extended and deep. There is a loss in surface in both cases, but what makes the difference is that for only one of them, we also assign a shape that is round. So as you can see, more or less, the idea of this new method is to taking out the interpretation and only considering how it behaves every alteration in the effort to discriminate different categories. So thanks to the percentage of completeness, because we know that that bone belongs to an individual that we recognize spatially in the distribution of the site, but also because we know the environmental context is a volcano. So from once in a while, we know that faults were dividing and affecting the site. And in this way, we know that maybe some volcanic activity has to be taken into account regarding the alteration. So the mix of all this information will be what we need to reconstruct patterns of the alteration, and this will ultimately lead to the preservation reconstruction. And to do this, the further analysis is to extend the same data collection to all the individuals that they have in the site. And then we will apply for all of them bone thin section and chemical analysis. This is because we try to pinpoint exactly what it represents every alteration. And right now, discriminating categories will make us easier to understand if maybe we're seeing something different, but is producing more or less the same effect, or maybe not. Maybe through the chemical analysis, we'll just define, no, even though we see them in a different way, they still belong to the same. So this is what will help us to reconstruct what happened in the site and probably go closer to the cause of death of this animal. And thank you very much for your attention.